So today's class is about the decision tree, and people would think what a decision tree looks like. Do we use it often? I want to ask you guys, do you like, we have to eat every day, right? I want to use like eating dinner as an example of a decision tree. For example, tonight, where you want to go to eat. So you need to make a decision. You want to eat at home or go outside. That's the first level of decision. Then you will think, okay, I want to eat outside. That's fine. Then go to the next one. You eat outside, you want to go to a restaurant, eat inside the restaurant, or just buy the takeaway order and bring home again. Okay, then you make another decision tree and decisions. Then go, when you go to the restaurant, then you check the menu, you decide, okay, I want to eat inside the restaurant. Then you look at the menu, you make a decision again, so on and so forth. This is the simple daily example of a decision tree. And now we talked about a little about the daily life decision tree usage. And in the decision tree, you can see that you sometimes use algorithm, use some reasons to decide how you want to make a decision. And in our class, we will talk about the recursion and also decision tree algorithms. And then in the lesson 3 and 4, we'll go through a project that will help you to do the coding and see how the decision tree was built in Python and how we can use it to make decisions. We talked about the decision tree right now. I do want to get you guys engagement about how you use the decision tree in your daily life. Give me some example. So here is, I want to engage the students to talk about the decisions they want to use. No wrong answer. Basically, encourage them, get their attention, and talk about the decision tree in their daily life.
Makes sense.
Yeah. So those are very good examples of decision trees in our daily life. And I also learned some decisions, how you guys make decisions right now. Now let's look at a typical decision tree. So what it's about? It starts with the root node and is a flow chart like a tree structure. Start with root, and we call the root node. And from the root node, we go to the non-leaf nodes, like neighbored in the chart, 2 or 3, 1 or 2. Those we call the nodes. And the connection between the parent node to the chart node is called a branch. And the final decisions are called the leaf nodes. Or the leaf nodes, there's no further kid nodes. Yeah, this is a decision tree. So it looks like a tree with a root, branch, and the leaf. Now we can see, we will talk a little bit about some definitions of those decision trees. But before we go to those detailed definitions, there are 2 types of AIs. One is rule-based AI. Another one is machine learning based on the AI. Rule-based, so you know exactly the algorithm, you know exactly the logic to make a decision, to jump from the selections to your decisions. For example, you know the weather is sunny, then you say, okay, I will play tennis. Or you say, outside it's so windy. Based on those facts, you make those decisions. this can be written by certain algorithm and coded in the Python. And typically, we had a lot of examples of those decisions because to make those decisions, we use human knowledge, and the guidelines is simple, can be coded as a simple algorithm in the computer language. But a lot of times we have that machine learning type one. It's really hard to come up a simple rule to make that decision. The easy one is like, the simple example is when we look at an animal, we can tell it's a cat or dog. But how did you describe a cat? It's not a simple way to do it. At that time, a machine learning approach is use a lot of data and use a fuzzy logic, neural network, and make the learn from those data, and then based on those learnings to make the prediction. Now let's go back to the tree structure. We talked about the root, the leaf nodes, the parent nodes, and then the kid nodes. So those nodes are the tree elements. Branches are connections between nodes. And we always have a parent node and a child node. If the parent node is always one step higher than the child node, and if a node without any children, then we call the leaf nodes. Now, I want you guys to tell me which node is the parent node. How many root node we have? Can we have 2 root nodes? And how many leaf nodes do we have? How many branches do we have? So that's a Q&A session, like get their attention. Oh, you already have there. I just one step further. We talked about the rule-based AI and also the machine learning-based AI. Let's look at a simple rule-based AI. We have a 3 decision logic there based on the outlook of the weather. Is that sunny or rain? Then based on the strength of the wind, is weak, strong, and also based on the temperature outside, is warm, cold. Then we make a decision whether we want to go to play tennis or not. So in the dotted blue circle inside, we have those elements of facts we used to make a decision. And in that yellow dotted part, that's the decisions we made. So we have the data, we have the decisions. And now we see how we want to get into how to build these decisions. We can always choose one category from outlook, say, then build the branch, 2 branches, sunny or rain. Then under each branches, we can, like in sunny branch, we started the child node as a temperature. Then from that node, there are also 2 branches, warm or cold. If it's warm, we say, and also, since the outlook is sunny, we say yes. Yes means we are going to play tennis. So those are based on those data we have, we build this kind of decision tree already, so on and so forth. On the rain side, we start with is wind. I think I can use mouse here. It's much easier. Yeah, we start on the rain side, outlook as a rain, and then we start with the wind. Then it's a strong or weak. Then from that parent node, and we build two branches, weak or strong. For the weak, we have temperature. Temperature, if its temperature is warm, we go to, we will play tennis. If temperature is cold, we say no. When the wind is strong, we say no, regardless the temperature is warm or cold. So that's, this decision is structured based on the information provided in this table. Now, we built this decision tree already. We started the prediction. That's the purpose of building this decision tree. We have examples, we have a logic built in, we have the data now. Then we use that data, follow the logic in that decision tree, then make the decisions. Start from the outlook. Now what do we have? We have a sunny outlook, temperature is cold, and we only have a weak wind. Start with outlook. Should we go left or right on the branch? Definitely left, because it's sunny. We were told it's sunny. We know it's sunny. Then on temperature, on this child node, what's the temperature look like? It's cold, not warm. So go this way, go to the right branch. Then since the temperature is cold, how about the wind? It's a weak wind. So choose this one. Hey, the decision is yes. So we are going to play tennis today. That's how we use a decision tree to predict or make decisions. Now, let's go back and review this decision tree. Looks like I want to say how many non-leaf nodes do we have? Those non-leaf nodes have featured names used to collect the data. For example, temperature, wind. And then we have branches. Branches are those featured values. Is sunny? Is that a rain? It's kind of the logic we are going to use to go through this decision tree. Then we have leaf nodes. Leaf nodes typically go to that's the decisions, because that's the end of the tree structure. You can reach decisions at the leaf nodes. Isn't that clear, or do you have any questions? Now let's do a design in the Python code to design your own decision tree. I have a question here. I have to stop. Is this the time to ask them to build a decision tree? Because that looks like a example to, or is it time to build a decision tree?
So this is you like draw it out. You know, if you look at the previous slide, see how there's like a decision tree model where you like basically do that. The students should create something like that on their own. It's like draw it out with, you know.
Oh, draw out. Okay.
Yeah.
So based on this tree structure, could you recover what's the original table we have we could use to build this decision tree. That's the purpose, right?
Okay, so something like that. Yeah. So you're given this table, right? In the previous slides, we made these slides at least created this decision tree by splitting the data using Outlook first, then temperature, then wind, and so on. The idea is to ask the students to do the same thing, except in this case, try to let them do it by themselves. And then also, instead of using Outlook to split the data first, maybe you can first look at the temperature or first look at wind, and then make a decision tree on their own.
Okay, I see. Now I see. So let's go back to this table we used to build our decision tree. And just imagine you are the one to build that decision tree. On your paper, write down a decision tree and show me in front of the screen once it's done. That's the purpose of these slides, right?
Yeah, basically draw a decision tree on it.
Yes. Now, after everybody showed the tree on the paper they draw, now it's time to ask them to set up the coding environment. And that's the part I'm not very good at it. I think last time during the demo part you show me, it went very quick. But what I did is I already had the Jupyter set up in my computer. I just used it. I did not go through the README file. This is the part I view we will have quite a lot of IT related questions because each person's setup of their computer setup may not be right, may not be exact same. The version of software they have may not be same, so it could have a lot of hiccups here.
Yeah, that's the same as the package installation actually. It's always the most one is always the most boring part of the class, right? And two is always there's always gonna be someone who's having trouble downloading the package or opening it up. So whenever that happens, basically just send a message to me basically, or someone in charge, I guess, at the time. And then we'll either try to solve it right immediately or try to record the situation, basically write down whatever the error message is. And then I'll ask and then we'll figure out after class what we can do to fix a problem. Yeah.
Yeah, I think it is good to recommend them if the problem couldn't be quickly solved and after class stay in the Zoom meeting for another 5 to 10 minutes and you can jump in to help them to set up.
Yeah,
but,
that works too.
Yeah.
Usually,
I'm thinking you couldn't access their computer, right? You couldn't remote control their computer.
Usually speaking, I'm pretty sure if you already have the package downloaded, even if you run the line again, it shouldn't matter that much. It will just say you already downloaded the file, you don't have to download it again. It will just automatically not download it. But there is going to be some errors, and in most cases, it's probably simple errors in the sense that they didn't they're change the directories like cd into the correct folder to download the requirements.txt file. That happens a lot. In some cases, that's actually the most common case. Yeah, if there's but there are probably going to be odd cases. If that's the case, just take a screen. Ask them to take a screenshot of what the error message is, and then send it to me, and then I'll figure it out.
Now we go to the algorithm part, and we had a basic knowledge about what's a decision tree, how it looks like, and how it worked. Now go to the logic we want to use to build the decision tree, and the two of them we want to use. One is called the recursion, another one is a decision tree algorithm. Recursion is A typical example is calculated the nth Fibonacci number in terms of the n. So we can define when n equals to 0, what's the Fibonacci number would be. Then 1 equal to 1, what is the Fibonacci number would be. Then what after n equals to 1, then we use the recursion equations, which is the n equal to what? Why this one is kind of
Right. So if you actually press the slideshow button, like present it, it's like animated.
slideshow.
Yep.
Okay. I see. What is recursion? So we define those small instances, and then large instance, we use those small instances to solve it. This is the Fibonacci sequence number. When n equals to 0, then it's 0. This is a Fibonacci sequence. 0. N equals to 1, then the number equals to 1. Then after that, it's if n equals to if n minus 1 plus n minus 2. So that's the basics of how to define a Fibonacci number in terms of n. So when we look at it, we start with Fibonacci's numbers n and 1, then we get 2. Then from 2 and 1, we got the Fibonacci's number 3, so on and so forth, and keep moving to the n you want. There are 3 laws of the recursion. Number 1, you have to start with a base case, and then the algorithm must call itself recursively, and they move forward from the base case to the number you want to check. So the base case here is n equals to 0. We have if n equals to n equals to 1, then if n equals to 1. When we further calculate the higher n, then we use n equal to 0, n equals to 1 to move each step further till we reach to the n you want. This is a relationship or logic we are using to build this recursion result. A real world example to use this recursion logic is climbing a stairs. So the rule is each time you can either climb 1 step or 2 steps. So now you have a staircase of n steps. How many distinct ways you could use to climb to the top? Let's start from the base. When we have 1 step, we only climb once. We have 2 steps, we need to climb twice. We have 2 distinct ways. We either climb 1 step or we climb 2 steps. So they're equal to 2. So when we have 3 stairs, we can have the distinct way to climb to the 3rd stairs is either we climb one, or we it's kind of a combined the way we climb because let me reword, because each time we can climb either 1 step or 2 steps. If it's a 1-step case, then we recur back to the f n minus 1, which is f2. If we decide to climb 2 stairs at that time, then it go back to stair 1 case. So that's F1. So in order to climb, the distinct way to climb to the 3rd stair will be the F1 plus F2. With that logic, we can continue calculate till we reach to the top of stair N. Base case, recursion relationship. Yes, I think I explained. Yeah. Now go to the quiz. Climb 1 or 2 steps. We're climbing this staircase, and we know it will take. It has the n steps. It has n steps to reach the top, and each time we can either climb 1 step or 2 steps. So how many distinct ways we can have to climb to the top? We talked about the base case. Base case, there are 2 scenarios, only one step, or we have 2 steps. For 2 steps, we have 2 ways, climb 1 step or climb 2 steps. Now, what's the when the steps are more than 2? We have that recurrence relationship. Fn equals Fn minus 1 plus n minus 2, Fn minus 2. So that's the climbing staircase. We can use this logic. That's the structure of the Python code we should use during the coding. I have one question. I was checking. I did not see building a decision tree on this recursion part.
So this part is connected to the next part where you remember that slide was like the algorithm, where it's like different lines. So this leads into that basically. You just click a few more. Just click a few more. You'll see. Yeah, it's just an introduction to basically the algorithm you see.
We talked about the recurrent logic. Now let's look at the building a decision tree with recursion. Sorry, I did not see the recursion here. How do I use the previous small case? That's confused me.
So the recursion, how recursion works here is this idea that recursion is breaking down big problems, small problems, right? And in this case, you have a big data set. You first split the data set into 2 halves, and then you just, for each subset, you split it again. It's the same splitting process. You focus on one feature. For each value, split the data set into different subsets. And so since you're doing that over and over and over again, that's the recursion relationship right there.
me see. I missed this part. I saw the sunny or rain. It's quick.
You can click a bit more. It's all animated actually. And then the next one will be like you see the algorithm and then whatnot. Pretty sure.
I see. It's different from what the decision tree we talked at the beginning is kind of using the recursion to build this decision tree.
Yeah, exactly. In the beginning, it's just introducing the structure called decision tree.
Yeah,
And now
yeah.
it's actually building it using recursion.
Okay. Building this one with a recursion. I see. I see. I need to think how to present these slides.
It's fine. I think if you look over it a bit more, you definitely can teach it. So honestly, yeah, let's go over this slide first. Or if you think you can do this one, if not, that's fine either too.
Now we start to use the algorithm to build the decision tree. Then we start with the build a tree and we understand the value of the, why is it called the best feature? Why is it called the best feature?
So remember that in the first example, we used Outlook, right? We picked Outlook and then we split the data set into two different subsets.
Yes.
So basically, the best feature A is obviously you can pick a random feature, right? But if there are a lot of different features, we want to pick the feature that splits the data most evenly. And so that's hence the best feature. Now, there's a whole bunch going on behind that line, like gradient descent or whatever. We just basically in the actual code, there's a helper function that just tells us what is the best feature. Students don't actually have to code this part. They just have to say, all right, call this function to find the best feature. And that's simply because it's a bit too complicated for students to code this at this point. So that's basically what's going on here. Basically, we just use one line to find out what is the best feature to split the data with, and then we just use that feature.
And tell me again how that best feature is defined, because it's kind of separate the data into almost the same quantity of two pools up with the same quantity, or is the easiest way to draw the conclusion to reach decision, to make decision?
Yeah, I think the second one. It's the second one. Again, students don't have to know this immediately. This is just basically saying, okay, use this line to find out what is the best feature. But really, what's going on is it's a feature where if you use that feature, it's like the first half have most of this, like it's more both sides become more pure basically.
I will Google to see how you guys define the best feature.
Again, yeah, you don't have to. Again, this is it's definitely good looking into this. I think when I thought this is, looking into this definitely helps understanding it. But when you're teaching this to students, you don't focus too much on how this works.
For me is I want to know once they ask this question, I'm kind of preparing myself more than I should teach them. Yeah, I understand.
All right.
And so we have all the database set up with the class labels. We call it a tree. It's an empty database. Then for each feature, and we figure out the best feature, which will be given to you guys at this moment to save time. And for each value in that feature, and we define the subtree and attach this subtree to the corresponding in branches and start to build this overall decision tree. So we started the feature of Outlook, and then the branch will be the Sunny, and based on this branch, we build a sub branch and called the temperature, and then we choose the feature inside that branch called temperature and break them into warm and cold 2 branches. And at the cold branch, we have another feature called wind. Then we have the, I'm sorry, I don't think I know what that means. I did not word it very well. Yeah. Then we can make a decision on yes or no playing tennis by the wind, the wind feature, that the branch is on the weak or the branch is strong. It's same for the Outlook branch of the rain. And then we have those sub values, sub values we have. In those sub values, then we break into them into branches like weak or strong. And under the branch of weak, we have another feature called the temperature. And there's a sub feature of temperature have 2 branches. And in this way, we build the overall tree. Once we finish the building all the branches and the sub features, and we put them together, return back to that tree, then the whole decision tree is built. In the quiz, so this is the quiz or this is the time. I thought this will be the third or fourth class for this one. But or you say you want me to teach this and ask them to build it on the paper in the second class?
So the first you see, remember that building decision tree part, build your own decision tree, that's the end of the first class. Just write it on the paper. This is technically a second class where it's just a quick quiz, basically a quiz about what you just covered, like the last slide. It's the exact same thing, except now it's, you know, fill in the blanks. I just click through a bunch, you'll see. You see what I mean? It's just like a fill in a blank kind of thing right here. Just ask the students, hey, what is it? What's the first line? What's the second line? What's the third line, etc.
The students will write something like this or still going back?
This is just interaction. Basically ask the students, hey, what's the first line? What's the second line? After you go through the explanation on this side.
The students will write on the paper, on their paper, decision tree like this, or they write on the paper on like a more logic of this.
Logic, yes. They don't have to write. They don't have to write anything though. It's just
just answer the questions, fill up the blanks. Okay.
Yeah, exactly.
To see whether they understand the previous steps. Clear.
Yep. All right. Okay. Also, never mind. Yeah. Sorry. Sorry.
I myself pretty much stopped here because I did not go further on the Latino, the switch case. So.
All right, no problem. So yeah, that's fine. That's fine. Do you want to go over the code part of the recursion? Do you know that climbing stairs Stare stripper notebook.
Yes.
All right.
Yes. When I try to run it today, I have an error message here as no mode called the term color. This is what, before you answer this question, I want to know that when I run in Jupyter, there are also some terms I'm not very familiar with. Return if, return, those are no, but I'm looking for some reference like from term color, where to find this term color, and for sentence, like for the comment or code like this, where I can find more detailed explanations. When I use JavaScript, I was going to a website. When I type those like term color, it will give me examples, everything. Where to I can find those in term of Python.
It's same thing. Just type this like Google Python package color or yeah.
The one I used is called MDS or something website. It's very detailed with like could do the keyword search, and they also give me examples. I can do a Google search. I just want to find some website with good credential.
I think if you Google, the first top results all are pretty good. I mean, usually the first thing it tells you is like the documentation, the package documentation, or like Stack Overflow sometimes nice. Or yes, Wikipedia's all nice. Now I want to mention one thing. So two things actually. So the part where he says like import colors or whatever, that's the testing area. You don't actually have to do anything there. Like the students don't have to do anything there. You don't even need to explain what that is. All you have to do is just run it, because if the goal is to implement the first part, like the recursion part with your students, and then once you've done that, you run the next cell to just test it to see if the result works out. Right? You don't have to do anything there. Does that make sense? And also, I think in the module, it didn't work out. Like it's gave you an error message. I think it's because you didn't install requirements.txt.
I think so. I think the one I had before may not be the exactly the complete package.
Yeah, so just download that again if you can.
Okay.
Yeah.
Let me share. Hold on. I may not share the right one. Okay. I think this is the one. Yeah. So how you want me to go through this coding part?
Just the first cell is if you move up, right? It's just the part where it says, yeah. For all of the code, every time you see like a test, you don't have to do it. You don't have to do anything there.
Basically, I will ask a student to copy the code. I mean, after install the software package and copy the code to their screen and start to run it. And if they have any questions.
Let's start something like that. Well, the approach is first you want to start with a blank screen, right? And then you code the whole thing out and explain what's going on. And then the students will just watch and try to understand what's going on. And they shouldn't be coding anything at the point. When you're done finishing explaining, like switch a tab so you don't show the code anymore, and then ask the students to recreate what you just did. Like ask them to like from what you just explained, see if they can write it out. Obviously they can't do it the first try. That makes sense. So then you'll like come back in and then just help them out if they get stuck on anything, or just do over like explain some part that may be confusing again, or etc.
I'm going to type, or I just copy paste.
It's better to type it out. Copy paste is just right now it's fine, right? It's just like 4 lines. If you just copy paste, that's fine. But for like the later projects, there's going to be a lot of lines, and if you just copy paste, it's going to be too much all at once.
But for the switch case, like by switch case, if I don't copy paste, there's so many lines I need to.
Yes, so don't. So the idea is, you have two screens, right? That's the best way to approach this. One screen you have your solution where you don't show your students. Other screen you show your students. And then so there's a lot, but actually, there's a template. I don't know if the template's in there. I need to upload that. So you don't actually have to write all of it. It's just a few lines that you need to add in, because the
I see.
template has most
Use
of it.
template will help. Yeah.
Yep.
I read those one. I read this one on the climb stairs, but I did not run through it because since I have an error message at this moment, I stopped. But basically, first to define a function called climb stairs and clearly define the base case, because base case are given ones, then return the climb stairs result, the recursion logic we are using. Now, next, we input the color. I will check more details on this one. We have a array of stair numbers, and then we want to read this array of stair numbers, generate the answers, how many distinct ways to climb to that step. Is very clear with defined base case, step one, solution is one, step two, solution is two. How about the 3, 4, 5 till n? Then that's the time we write this recursion equation. So first we want to the range of this array. How many elements we have?
Okay, sorry, I just want to add in. So you don't have to, explain anything in the test case, right? You just need to explain the previous time. The test case, you just run it to see if it works. Like, yeah.
Oh, okay. So basically, I just click run and then show them result and ask them to. Oh no, I think I will use the template first and type in a few lines, make it a complete runnable code, and then run for them. I don't have to go through each steps.
Yeah, basically, code the part that it says you need to code it. For everything that says test, the point of the test cells is to see if like the stuff you coded is correct. If you have the package installed, it's gonna give you the outputs, and if it'll tell you, okay, you did it wrong, or okay, you did it right. Like it'll tell you if you did it wrong or right.
Then I will help them on the error message part.
Yep.
Okay. And the students will be provided with that template too. They just type in. Okay, that's clear. That's much better than typing every line. Yeah. Okay. That's pretty much in what I have went through yesterday. I just barely started last night. So I did not go through the slides like you showed me. If I know, and I haven't got, I will, like, I believe you posted your teaching video, the whole teaching video online, right? I could go through that teaching video, see how you use the slides.
So no worries, just I understand. I think a lot of other people do this too. Just look over the materials for this class, and then and then you can do it after the evaluation. That's perfectly fine with me. So before we end, I guess a few comments I have. Let me see.
I missed your last sentence.
All right. Oh, let's see. All right. So yeah, that basically wraps up the evaluation. I think so. Overall, great job.
Can you stop recording?
Yep, I can. 1 second. Stop recording.